Appendix 5 on page 11 shows in the middle of the page, it says half-wave rectifier circuit, no filter capacitor with a transformer. So you've got an AC voltage coming in, AC input waveform, and what does it say about the resultant output waveform? It's going to look something like this. So here's the voltage coming in, and the voltage coming out is going to be something that's going to look like this. You see? And this is what you're going to now draw on page 2. So let's all go to page 2. See the graph at the bottom of page 2? The first graph is V secondary. So let's first label V secondary. On that V secondary, the first thing you're going to label is the 0 volts, right here, in the middle. And the next thing you're going to label is the peak value. How much?
11.31.
11.31. V secondary peak. Okay. Now let's go to V out. V out, what you're going to do is you're going to draw a positive peak followed by a 0, and then so for the plus here, you're going to show the plus here, plus. But for the negative, you're going to end up with a 0. So let's draw that for V out. And you've got the dotted lines to help you guide where the peak value is. Okay? And this value here is how much? 10.6. And show the 0. So next week in the lab, we're going to take our scope probe and we're going to connect the scope probe right here. Okay? And what we will see is a voltage like this on the scope. So depending on where you set it up or down, once you identify the 0, then you measure from that line to the top, and it'll read 10.6. Make sense? So that's half-wave rectifier circuit. So now, the last thing then is VDC average. So let's now calculate VDC average. So, what does VDC average mean? Well, let me take you to an appendix. Page 10. Go to page 10. Appendix 4. That's my graph. This is what I have for the voltage at the load. Okay? It is called a pulsating DC voltage. It's voltage that goes like this. Okay? And I can connect a DC multimeter here. I can connect a multimeter like this. And read a voltage. And what I will read is the average of the voltage under the graph over one cycle. So first of all, tell me what I mean by one cycle? Where's one cycle of this graph? If I start here, where's the end of the first cycle? Is it here?
No.
Or is it the next guy here?
Yes.
This is one cycle. Okay? So the area under that graph is the average of this area here is what I will read on a DC multimeter. And I need to do a little bit of calculus to find that answer. And that is what this math in the middle of page 10 shows, that the DC average voltage works out to V peak over pi. V peak over pi. For this half-wave rectifier circuit, do you see the V peak over pi in the middle of the page? Put a star beside that. V peak over pi. So now let's go back to page 1. And for VDC average, indicate that to be V peak, V out peak over pi. Because that's what I will read on a meter. So what is my V out peak value? 10.61 divided by 3.14. Pi is about 3.14. So what is 10.61 divided by 3.14? 3.38? 3.38 volts. And can you draw a little picture beside it that looks like this? And write down DC. So that's what you will read on a multimeter at the load with the multimeter set to DC. Okay? So what we just did here is this. Watch. If I was to show this as a block diagram, I've got AC coming in and
DC coming out.
DC coming out. Do you see that? And this is my rectifier circuit. Okay, so